Welcome back to Quanta Academy, where we will learn about TFT, which is temporal friction theory. So welcome back, guys. Today I just wanna, our first lecture, we have to first define all the terms that we are going to use in temporal friction theory. So temporal friction theory with vocab. So our first term is temporal field. Temporal field, which is a continuous field that fills the universe. And flows in a preferred direction, creating a temporal river, and all physical motion is the result of objects being carried by this flow. This is our definition of the temporal field. So for this temporal field, it has a role. So I won't write the roles, but I will just share them with you. The roles of this temporal field is to determine how processes evolve, create gravitational effects through tilting, and create inertia through resistance to redirection. The fourth one is to create quantum behavior through fluctuations. So in TFT there is a lot to learn, because TFT will touch some phenomena of quantum mechanics, and also reinterpret and explain the relativistic phenomena, and also so our second term is universal temporal flow. So we define this term as the natural straight line direction of time's flow in empty space, far away from mass. Energy or acceleration. Now, so let me just give you deep details. It acts like the default direction of temporal river. In special relativity, this corresponds to proper time in flat space-time. So now we define our third term, which is internal time, which it's simple, it's tau. So the definition of this internal time is the rate at which physical processes occurs inside an object, which we can define as the examples, which could be oscillations, chemical reactions, atomic transitions. So this internal time is what a perfect clock measure. So the key idea here is motion slows internal time, gravity slows internal time, high temporal resistance slows internal time. This is how in TFT we naturally produce time dilation. So now we come to our fourth term, which is external time. External time, which is T, the usual T. Then definition. The universal time. The universal time of temporal. Universal time of temporal field itself, which is the rate at which the field flow independently of any object. Everything in the universe is embedded. Let me write it down. Everything in the universe is embedded. Everything in the universe is embedded in this. So here is the key thing that defines general relativity. So internal time versus external time differences create relativistic effects. So relativistic effects are created by the difference in external and internal time. So here is the fifth term, which is temporal gradient. So these are terms that we're gonna use as we continue with our lessons for temporal friction theory. Temporal gradient, which is denoted as, this is our symbol of temporal gradient. It's just a change in the direction or strength of the temporal flow. So this is the TFT definition of gravity. So gravity is just the temporal gradient. Gradient. So G is equal to, so this is our definition of gravity. So strong gradients equal, let me write it down, strong gradients equal strong gravity. Then weak gradients equal weak gravity. Zero gradient equal zero gravity, which is free floating or weightlessness. So let me also show this. Objects accelerate because of the temporal flow. Objects accelerate because the temporal flow bends downwards to mass, not because a force is pulling them. So this is our definition of gravity. Objects just accelerate down because of the spatial gradient into the spatial gradient of the flow of the temporal field. So like here, why the gradient is because matter imparts the flow of time. So the presence of matter introduces gradients in the flow of this field. So the temporal field starts to bend down to mass. So this is equal to the space-time curvature in general relativity. And then come to our sixth term, which is temporal resistance. This is the special term in temporal friction theory. Temporal resistance temporal resistance, which has, this is the special term, which is mu with a subscript of g. So why this term is special in temporal friction theory? Because let me just give you the definition, then I will tell you why it is special. So it is the opposition an object experiences when changing orientation relative to the temporal flow. So this temporal resistance in modern physics, we call it mass, which is also equal to inertia. So objects resist this flow. So why objects resist this flow? Because their internal time, which is internal time, their internal time is equal to mass. So their mass is just their internal time, which is trapped time. So objects with big or great trapped time, they have greater mass. Objects with less trapped time, they have less mass. For example, light has no trapped time, thus massless. Light experiences no time. Light has no internal time. So since light has no internal time, has no mass, has zero mass. So which gave us the conclusion that mass is equal to the trapped time or your internal time. Because everything that has an internal time has mass. It's only light that has no mass because light has no internal time. So inertia, which is given like this in TFT, both inertia and mass. And this will explain why inertia and mass are equal or are considered to be the same. Because it's the internal time. So when you accelerate an object, its internal time resist to be realigned. So I can say this internal time is like our compass, internal compass. When you are stationary, your internal time points down. It aligns with when you are on planet Earth, just not moving in space. Your internal time points down. It aligns with gravity. So that's why you are accelerated down by gravity. Then, but if we accelerate you this way forward, your internal time now has to realign to face this way. Has to face this way, then you are here being accelerated. So you will feel a push, a backward push. Not that it's a force, because your internal time is realigning now. It's pointing back. First it was pointing down when you are not moving, but now we are forcing it to push it to take it out or to point back. So when you are standing, your internal time is like this, but when we accelerate you, it changes to be like this. That's why. So force is the amount of, so force, I can say force is the amount, force. A force is needed to realign your internal time. That's why when you are moving, so your time is like this. So when you are being accelerated, your internal time points backwards. It aligns with the horizontal movement. So it always aligns with the movement, because when you are standing, your internal time knows that we have to move down. We have to move down first because of gravity. Then when you are moving to the right, your internal time points back. So it first resists to be tilted, but then it tilts. Then you start moving this way. As you move this way, your internal time is now like this. So, and this is not something that happens instantly. So when you are moving, then when you stop accelerating, your internal time is like this, is pointing at the back. So when you stop, it just for the time to realign with gravity, to change realignment, you go forward. So you just go forward as if there's something pushing you. Not that there's something pushing you, it's your internal time trying to realign with gravity because you are now not moving. But we will explain that deeper in the upcoming lessons. Then, so now let's give you the seventh term, which is, okay, let me just explain temporal inertia. Just give the definition. Inertia, which is a measure of how strongly an object resists the change in the orientation of its weld line relative to the temporal flow. So this is our definition, and I can say, and maybe this definition can replace or can explain better Newtonian inertia. So then weld line. Our eighth time, it's weld line, since I've used the term weld line here. So now I have to explain it. Weld line. Weld line is just the path. The path an object draws through the temporal field. So at rest, it's perfect alignment. It's a perfect alignment with the temporal field. Then moving, when you are moving, so your weld line gets tilted. Accelerating, then curvature. Changes when falling and when free fall. A forced alignment with gravitational gradient. Then the last one, but the list is inexhaustive, but I'll just end here. That was 8. That means this is supposed to be 9. So 9, which is the temporal tilt, which is our theta. Definition is just angle between an object's weld line. Object's weld line and the pure vertical direction. Pure vertical direction of the universal temporal field. So let me make an example. This is space, this is the flow of time. So if you are stationary in time, your weld line is here, this is your weld line. But once you accelerate, because you are now moving in space, also moving in time, like this, so this line become your weld line. And if this is your weld line, this is the angle, temporal angle. You have tilted your weld line from the pure time to this. So that is explained by the temporal tilt. So thank you so much, guys. Thank you so much for watching. For more, please subscribe. For more, please subscribe. There is more to learn. For more, please subscribe. There is more to learn. Thank you so much, guys.